In this lesson, you will learn how to read the shape of land from what you can see in a landscape and on a simple map. Look at the wide scene in front of you. The ground rises, levels out, dips, and stretches in different ways. Imagine that you are looking at this place for the first time. What clues in the shape of the land could help you describe it clearly? A landform is one natural feature of Earth's surface. Terrain describes the overall character and shape of the ground across the wider area. Notice what the whole view is showing. A landform is a natural surface feature. Terrain describes the wider ground shape around it. We describe the natural surface, not human-made objects on it. Landform names one natural feature, while terrain lets us describe the ground across the wider area. That distinction helps us describe a landscape. Terrain describes the overall ground character. A landform is one natural surface feature within that wider view. Use the two labels in the picture. What is a landform and what does terrain mean in the scene? Let's match each word to the visible clue. A landform is a natural feature of Earth's surface, while terrain means the overall character and shape of the ground in an area. The outline shows one feature. The bracket shows the wider ground. Next, we will learn 3 clues that make terrain easier to describe: elevation, slope, and relief. Elevation tells how high the land is. Slope tells how quickly it rises or falls, and relief describes the variation in height across the area. Keep the 3 clues together. Elevation, slope, and relief describe different clues. Together, they help us read the terrain more carefully. Elevation, slope, and relief answer different questions about the same terrain. Using all 3 prevents us from describing the land from height alone. This makes the measurement idea clearer. Slope tells how quickly height changes. Relief looks across the area, while elevation describes how high a point is. Trace each marker with your eyes. How do elevation, slope, and relief give different clues about terrain? Now connect each marker to its meaning. Elevation tells how high the land is, slope tells how quickly the land rises or falls, and relief describes the variation in height across an area. Each clue answers a different question about the same terrain. Next, we will use these clues to distinguish mountains, plateaus, and plains. Mountains, plateaus, and plains are distinguished by reading elevation, slope, and surface shape together. Height alone is not enough to classify the land correctly. Use the same 3 clues for each shape. Landforms need more than one clue. Elevation, slope, and surface shape work together. Using one clue can confuse different landforms, especially high ones. Combining elevation, slope, and surface shape gives enough evidence to distinguish mountains, plateaus, and plains more reliably. The comparison works only when the clues are combined. Height alone cannot classify every landform. Slope and surface shape add the evidence needed for a better decision. Look across all 3 panels again. Which 3 clues should you use together to distinguish mountains, plateaus, and plains? The comparison gives us the rule. Use elevation, slope, and surface shape together to distinguish mountains, plateaus, and plains. Those 3 clues help prevent one-feature guesses. Next, we will see how relief colors help us read height patterns on a simple physical map. On a physical map, read the relief color legend first, then match those colors to the map. The color pattern helps show relative differences in height across the terrain. Read the legend before the colors. Relief colors show relative height patterns. The legend tells us what each color means in the map. The legend gives each relief color its meaning. Matching legend and map lets us interpret relative height patterns from above instead of viewing the terrain from the side. That gives us a safe map reading rule. Read relief colors through the legend, then compare the color pattern across the whole map. Use the legend before you answer. How do relief colors on a simple physical map help you read the land? Follow the color link step by step. Use the map legend to connect each relief color with a relative height band, then compare the color pattern across the map. The legend turns color into usable relief information. Next, we will use the same evidence to correct the idea that every high place must be a mountain. Both mountains and plateaus can have high elevation. To identify a mountain, check slope and surface shape as well as height. Focus on the evidence, not height alone. High elevation does not prove mountain land. Slope and surface shape must support the decision. The shortcut fails because mountains and plateaus can share the clue of high elevation. Slope and surface shape provide the additional evidence needed to classify them. The evidence corrects the common shortcut. Classification needs more than shared height. When elevation is similar, slope and surface shape become decisive clues. Test the crossed-out shortcut. Why is the statement, "every high place is a mountain," incorrect? The two profiles show why it fails. High elevation alone is not enough. Slope and surface shape must also be checked because a plateau can also be high. The shared height clue cannot separate the two examples by itself. Next, we will look at another common mistake, treating landforms as if they always have sharp, fixed boundaries. Real terrain can change gradually from one landform character to another. That means landform boundaries are not always sharp, fixed lines. Look closely at where one shape becomes another. Landforms can grade into one another. A transition may share features from both sides. Landform categories help us describe patterns, but terrain is continuous. Gradual changes in height, slope, and surface shape can create a transition rather than a perfectly sharp boundary. This explains why boundaries can look gradual. Landform labels are useful, not rigid boxes. Real terrain may pass through a transition between familiar forms. Use the soft middle zone as your clue. Why should landform boundaries not always be drawn as sharp, fixed lines? The gradual change gives the reason. Because real terrain can change gradually, one landform can grade into another instead of ending at a perfectly sharp boundary. The transition zone shows why a neat drawn line may simplify a continuous landscape. Next, we will bring all the clues together to read one new landscape and map evidence set. Read the terrain with elevation, slope, and surface shape, then add the relief pattern from the physical map legend. Combine the evidence and allow for gradual transitions. Bring the clues together one last time. Careful landform reading combines several clues. Use the landscape and map evidence as one connected description. The side view shows height, steepness, and surface shape, while the map shows the spread of relative relief. Combining both makes the landform description stronger and keeps gradual transitions visible. That gives us a complete reading routine. Observe, compare, decode, and combine the clues. A careful decision comes from connected evidence, not a single shortcut. Use the complete evidence set now. When reading an unfamiliar terrain, what evidence should you combine before naming a landform? Now we can state the full method. Combine elevation, slope, and surface shape, and use relief or a physical map legend when those clues are shown. That combination gives a careful, evidence-based terrain reading. You are ready to use these clues to read landforms carefully in new landscapes and maps.